This is what I would view right now as $1 trillion clash of views.
The question informally is, what will happen to large language models? Am I saying that large language models are not bitter lesson pilled and that they will be irrelevant and a failure? The bitter lesson says that look out if you're putting all of your eggs in the basket of human knowledge, because human knowledge doesn't scale. And a lot of stuff, a lot of effort goes into making them good tools that are useful to people, good summarizers, good translators, good question answers. So they're enormously sculpted by people, and so they are risking not being scalable. So one might expect that, yes, they would reach the limits of the internet data, and that it would be an instance of the bitter lesson. It would be another case where it will fail because it's relying on people tuning them ad nauseum. I've started by saying I shouldn't have an opinion on this because it's not my bailiwick. But
I guess you do have an opinion.
That is my opinion. that it's going to be another instance of the bitter lesson.
Welcome to the Darby Mills series, Intrepid Pioneers of the Next Economy, featuring discussions with entrepreneurs at the forefront of deploying machine intelligence and brainstorming sessions about where the technology may go at the limit.
Welcome back to the Darby Mills series, Intrepid Pioneers of the Next Economy. I'm Ajay Agrawal, co-founder of Intrepid Growth Partners, and my collaborators are Rich Sutton, Sendhil, Mullainathan, Niamh, Gavin, and Suzanne Gildert. In this episode, we'll discuss the debate that's bubbled up over the past couple of weeks regarding the bitter lesson, based on this recent podcast featuring Rich in conversation with journalist Dwarkesh Patel on the Dwarkesh Podcast.
Okay, so first question. My audience and I are familiar with the LLM way of thinking about AI. Conceptually, what are we missing in terms of thinking about AI from the RL perspective?
Reinforcement learning is about understanding your world, whereas large language models are about mimicking people, doing what people say you should do. They're not about figuring out what to do.
I bet you never guessed out of your, many decades of work on this that your 2-page blog would become the thing. Anyhow, I'll begin with Suzanne and we'll work our way around if just any comments people have on this. And then Rich, just let you respond. You can kick off in terms of just your reactions to that discussion and language model and reinforcement learning views of the world.
Mm-hmm. Yeah, I'm thinking I just love to hear Rich's retro review on the bitter lesson now and how it's sort of having these waves of effect propagating through everything. So, rather than me comment anything specifically, I kind of want to hear Rich's take on whether he thought A, it would have the reach it's had, B, whether there's anything he would change about it or rethink about it in light of these new developments.
Sure. So we can turn to Rich to respond to that. And Suzanne, I just want to ask you to your own reflection of, Rich said something on that podcast that I've heard you say, which is, he said, if we could build something equivalent to the mind of a squirrel, we'd be almost there. And the host of the podcast, was talking about humans and ability to go to the moon and this and that. And so it felt like this huge difference between sending spaceships to the moon versus a squirrel hiding its nuts. And yet I know you have a view of the world that is much closer, I think, to Rich's.
Yeah. So I think about the sort of the squirrel issue is I think that building a mind of a squirrel is much harder than building something that can, say, perform using what I describe as advanced supervised learning. Because everything we're doing at the moment is supervised learning, right? There's no real true RL going on. Anytime anyone tries to do pure RL, they always end up doing imitation learning. Because I believe, and maybe if I'm offending Rich here, I'm sorry, I think pure RL is difficult or impossible because we can't define general purpose reward functions. So I think until we can find a way of either defining general purpose reward functions or otherwise accessing them or creating them, then I don't think we're going to be able to use RL to the the max. And what I think that would look like is you can take something like a squirrel and it will kind of autonomously start learning on its own. So you can take any agent, put it into a novel environment, and it will start learning on its own. And no systems we have today can do that. So that's the difference between the systems we need to build and the kind of systems that are what we think of as being intelligent agents at the moment. They're very, very smart and intelligent, but if you put them in a new scenario, a new use case that they've never seen before, they can't learn. So it's that learning component that's important here, not the what can it do, what has it learned. It's how does it learn new things that's important.
Okay, let me go to Niamh and then Sendhil, and then Rich, you can just pull on whatever thread you like.
Sure. Maybe as someone who's like sitting in the fray of all of this activity, I'll kind of give a quick end to end of where everyone's thinking. So I'm always kind of somewhat surprised by how the Valley's supposed to be the home of liberal thinkers. It can be remarkably tribal at times, whereas I prefer to beg, borrow, and steal from all camps. So ideally, when we're setting up these models, yes, of course, we'd like them to learn from first principles and discover and learn itself through experience. But there is a cold start problem to that. And that's why folk have used the proxy of let's just ingesting the internet. And the reason for that is kind of twofold around. They think that writing is a good indicative mechanism for our thinking mechanism, and that language is a key element that differentiates us from others. So therefore, it should be a decent enough proxy to start with. The challenge is we've kind of gone all in on extremes at every element of the model. So RL is supposed to be that good mix of exploitation versus exploration. Instead, all we've done is exploit, with limited experience or value functions embedded within it. And that has resulted in a more, exactly as Suzanne was saying, more pattern recognition versus true understanding, more imitation versus intuitive thinking. And the autoregressive mechanism itself is almost like an unrolling of a neural net, like a sequential pattern activation, as opposed to a true goal-based objective function that can be fine-tuned over time. So I don't think any of us think that an LLM and a good prompt is the future of AI. And ideally, we all want to move towards that elusive universal approximator that is generalizable, has transfer learning, has a general reward function that Suzanne mentioned there. And you are starting to see that shift now. People have seen kind of the limits or the brittleness of an LLM, and they're trying to create these more continuous learning mechanisms. And it's unknown whether that's back to your Bayesian approach or an evolutionary algorithm for leaps. And then there's a second element about the data itself. So it's not necessarily that the data is noisy, but is it even sampled from a distribution that we even care about, right? Like it's not based on patterns of thought. It is based on writing, and how we think when we write isn't necessarily how when we think in the real world. So that's why we're now seeing the sudden shift in embedded systems, which is moving more towards that mechanism of learning via doing, more of a value than reward function, and kind of less rules based and more exploratory era of experience. Then there are those folks who are like, okay, all of the AGI will be achieved by replicating the brain. And I'm not necessarily sure that that's the task that we should be doing. I always kind of feel that we should use computers and that mechanism to do things that we can't, and to double down on their strengths versus ours. And I do think there is a bit of a fundamental impedance mismatch there on like a brain in a dish, in the sense that, the computational architecture of AI is a simple electric circuit, where real biology systems are ions and they're slow, but they're highly efficient. And then it's like, is language fundamental to intelligence, or is it just connected networks? And maybe we just need new maths, right? So there's that kind of camp. And a fundamental element of all of this is, if it does do these big leaps, and this comes back to Sendhil's take, we do need some mechanistic interpretability to unpack these new designs, to understand, are they doable and how is it derived? It's a bit like that famous move 37 in AlphaGo, right? How do you kind of get the tracing and the causal effect in that? And then lastly, there's that kind of Feynman camp of, if I can't build it, I don't understand it. Yet we've somewhat kind of built things like CNN for vision and LLMs for language, and there's very little understanding of emergent properties. So there's kind of like a takeaway of, has it even helped us understand neural nets or not? So I think that's all these camps coming together is where the friction happens. But to me, it's where the overlaps occur is the most interesting part to double down on. So I think the bitter lesson has been taken to the extreme of like, is it bitter lesson pilled or not? Is a bit of a two binary approach mechanism for filtering things that is a highly complex task of, can we just fast forward and replicate 4 billion years of evolution? And, it's taken us decades just to get to the fly connectome, let alone a squirrel one. So maybe we should park our hubris a little bit and try and find, embrace more the scientific approach and exploration versus just a hammer going token by token. But we'd love to hear Rich's thoughts after Sendhil and all of this, because he's the expert, not me. I'm just a tourist and passenger in this journey.
Okay, thank you, Niamh. Sendhil.
So I found this one tweet that you retweeted, Rich, quite interesting, and he was just paraphrasing your tweet, but yours involved zebra finches, and I don't know what a zebra finch is. So I'm going to talk about what this guy Chris Haydick said. He said that your point was, when LLMs imitate, they imitate the action. When humans imitate, they imitate the output, but must discover the action. That struck me as at the very heart of the entire thing. And I don't want to say bad things about people online, but I just felt like a lot of people didn't understand that distinction. And I get why. It's very subtle. And I think the key here is the word discover the action, the word discover. In other words, you have a surface relation to the world. We all have a surface relation to the world. We see things. We hear the zebra finch's song. So that's the surface level. We don't have the mechanistic level inside of it. We see someone solve an algebra proof. We see that they did it in a certain way. How did they arrive at those steps? What step? So most of life, even very high level cognition, even when someone is explaining something to us, that's just a surface level. There is always a more foundational level at which we must use our own cognitive apparatus to say, how did that get generated? With the physical world, it becomes very clear. I thought your zebra finch example was very clear. It's like, I hear the sound, I want to make that sound. How can I know how the vocal cords that bird pulled together? That all I know is the sound. So I got to use my own vocal cords to try and do that. But with cognition, it's the same thing. Even when we're, quote, explaining things to get each other, just like, I don't know if you know this, I think this apocryphal story about von Neumann and the puzzle of the train. Do you guys know this? It's actually, it's probably apocryphal, where it's like, two trains are going towards each other and there's a bee going back and forth, and one of those things. How many miles does the bee travel? And von Neumann says, oh, here's the answer. He gives an answer. And someone says, oh, so you saw the trick immediately. He says, what trick? But there's a trick in solving this problem where you can get it and it's easy to solve. There's another way you could do it, which no one does, which is brute force your way through the series. And so I always like that story, because it just goes to show, even if you've sort of seen the output of cognitive effort, even if you had it explained to you, different people arrive at that. So I'm saying all this because to me, that was the most clarifying moment of the distinction, which is, if a model is forced to understand which actions will produce which outputs, it then must create its own representation of how actions relate to outputs. That to me is at the heart of, at least, and tell me if I got this right, Rich, but that to me is at the heart of one reason we might imagine these things don't have good world models, because they are not forced to ask which actions in some space will create the kind of outputs we see, whether they are language or proofs. But you can also see domains in which they've surely developed good world models, like chess or Go, domains where actually the algorithms have in fact had to go from action space to outputs, go from things to outputs. And that space is a big and growing space. It's just not the same space as language models trained on corpuses of text.
Okay, so we'll invite Rich to reply to whatever he wants. Rich, over to you.
Yeah, thanks, guys. All really interesting ideas. I guess I feel most of all that like we are all scientists, and we are focused on the ideas. But now we're trying to do something a little bit different. We're trying to comment on the sociology of the field. We're trying to talk about, I often just talk somewhat dismissively. I say fashions because there are fashions in our field, but that's too dismissive. It's more the sociology and these different ways of thinking. And it's always in science, you always have different ways of thinking, but this is more than that. This is like some way of thinking becomes economically powerful. Like, there are billions, hundreds of billions of dollars being spent on AI now because of certain ideas. And that sort of changes the science a bit. So what are these? I think I want to try to summarize. I mean, I've already indulged in the sociology. What is the bitter lesson but a sociological statement? It's not a science statement. It's really saying, oh, this is what people have done and maybe sort of why. It's a mistake that we've made over and over again. And so classically, I shouldn't say but classically, of course, AI has been about goals. It's always been about solving the problem. There's always been a problem, and then this is a new thing. It's even beyond whether it's reinforcement learning or not. It's a new thing to have a powerful thrust within the field of AI that says we don't need goals. We just need to mimic people, and by mimicking people and we do it well enough and big enough with enough computing power, and something qualitatively changes, and they understand now the world. They're not just mimicking people. They actually understand. They have a model of the world. And so I always feel this is an extreme claim. This is an extraordinary claim, as referring to the quote about extraordinary claims need extraordinary proofs. And so I think they're making the extraordinary claim. And I'm just sitting here saying, well, we've always known that goals and experience are important. It's an extraordinary claim to say that just by seeing many, many examples of what people did, just the next token, and then some fine tuning, that this will give us understanding and reason. They even go so far as to say reason. Yeah, so that's the first thing. I think their claim is extraordinary, but given that we are where we are and the fashions are the way they are, the claim that experience is important, that purpose is important, is held out as the extreme view. And the conversation today has to be about large language models. They are now the center. So after going through all that and the podcast and everything and the bitter lesson, I wanted to focus on one question. The question informally is, what will happen to large language models? What will happen to them? Because it's a question that I don't normally have to answer because I'm committed to another strategy. So I don't have to say, well, that strategy. And it's almost rude to comment on someone else's strategy. But that's really what the attention is coming from. People want to know, are you saying, as in, am I saying that large language models are not bitter lesson pilled and that they will be irrelevant and a failure? It behooves us to think a little bit and maybe form an opinion about will they be a failure? And they could be a failure just in terms of not achieving all that is claimed for them because of the enormous amounts of money that's being spent to produce these systems. And it's sort of like someone expressed it recently. Well, if the large language models and AI pays off in 15 years, that would be a disaster because so much investment has gone into them and so much promises have been made that if they don't pay off in 3 years, then there's going to be, a collapse or a bubble bursting, people's disappointment. And so I think that's the situation we're in, that they will certainly be useful for things, but there will be a bubble burst because it will not pay off. It will not justify the expense that's being put into it. So to say it another way, the bitter lesson says that look out if you're putting all of your eggs in the basket of human knowledge, because human knowledge doesn't scale. And so one interpretation is that this is exactly what's happening. So what do we know about? I'm not an expert in large language models. Maybe very few people are, but we can see that they are trained from human behavior, human tokens, and they try to reproduce the same token that a person would make. This would not make a good large language model today. They have to follow that up with a lot of fine tuning and RLHF, and a lot of stuff. A lot of effort goes into making them good tools that are useful to people, good summarizers, good translators, good question answers. They don't the fact that they focus on the person's question is because of something that's been added to just what happens in normal human language. So they're enormously sculpted by people, and so they are risking not being scalable because so much depends upon the human input. And the internet, although large, is finite. So one might expect that yes, they would reach the limits of the internet data, and they would start to be overusing fine tuning by experts, and that it would be an instance of the bitter lesson. It would be another case where it will fail because it's relying on people tuning them ad nauseum, and the world is big. It's incredibly complex. There are always going to be things that were not anticipated, and methods that could learn from experience, for example, and could notice all these quirks of the world will dominate in the long run. So even if a human trained, human mimicking system is pretty good, it might just have its lunch eaten by a system that started there, but also could train from experience. So I've first started by saying I shouldn't have an opinion on this because it's not my bailiwick, but
I guess you do have an opinion.
That is my opinion. That it's going to be another instance of the bitter lesson, and it seems very likely. It seems that could easily happen, and as I think about it more and more, it seems more likely than not that will happen.
And maybe as like a practitioner in the field, because I fully agree with you, Rich. But to the listeners, they might think, well, why does history keep repeating itself, and why does the industry keep sleepwalking into its own demise, right? So there's always this tension between what needs to be resolved by the model and the AI versus can be propped up via engineering. So that's why it's always great. The good labs always have a combination of research and engineering. But the downside of that is whenever the model hits a bottleneck or a limit, rather than stepping back to think, okay, how do we redesign it? The engineers are like, oh no, I could fix that. And so you end up iterating to kind of prop up a limitation as opposed to fully innovating and stepping back and refactoring the whole system and thinking, is there another way? And that's what causes it to become brittle and overfit. And then, as you alluded to at the start, AJ, when there's that market commercialization push behind it, it's like, well, we've kind of committed to a path, so we need to continue until we all get to a point where we realize we need to refactor and devise a new system as it's no longer scalable. And especially at the speed at which it's happening today, that's kind of the downward spiral we leap into. But at least the good thing is, if we get there faster, it will force us to reimagine. And I do think that is slowly happening within the LLM space, where you've seen it move from just that scaling law, throw compute, have a brittle kind of transformer backbone, to these more reasoning-based methods, which started with chain of thought reasoning and now moving more in towards an RLable environment.
And we'll have the innovator's dilemma.
Yes, exactly.
Which is
bingo.
What you're talking about. They've done it one way, and they tend to not want to try something totally different.
Yeah. Sendhil, go ahead.
I think I agree almost completely with you, Rich. So let me, on the substance of the matter, so let me slightly disagree on the second bit, which is, I think I would differentiate between two different things. One is what these models are assumed to be capable of, or thought to be soon capable of, versus what amazing things these models can and will be able to do. So to me, it's been helpful to just be like, somehow from seeing this behavior and extrapolation, people are imagining this is going to look like whatever intelligence, whatever you want to call it. And what's tragic to me is I think that extrapolation is misguided, but to me, that's not the tragedy. The tragedy is the things they can do are amazing. You just had a different name, just called it something else. It has incredible value, incredible uses. And it's one of these things that you see again and again where it's the problem is not a lack of something. It's like we saw it a bit in the internet bubble. It was not, I mean, the internet was transformative. There's no question. It's crazy to think that it wasn't. But somehow the attribution exceeded, certainly for specific companies. And so I kind of feel like the distracting part of this whole conversation for me has been, not us, but in the public conversation, has been we haven't had a clear conversation about the kind of miracle that's happened. Pure imitation has produced some really remarkable properties. How did that happen? How did we get so much emergent properties? What can it do? That's like a fascinating intellectual question. And yeah, it's not going to get to Intel, but I'm not many amazing innovations have happened that are not intelligence that we find good use for. And I feel like that's the part I'm most disappointed by.
And, I will say to Sendhil's credit on this, there's a lot of people in economics writing, doing studies of this, and most people in the titles of their papers and the language of their papers use the term artificial intelligence. And Sendhil doesn't. Like he has this paper coming out soon called something like Science in the Age of Algorithms, or Algorithms in Science. He uses the word algorithms, not AI, even though what he's talking about is what everyone else would call AI. And so
good on you, Sendhil.
Yeah, I'm amazed Ajay noticed. Yeah. I'm very careful about that. Yeah.
And so there's been so many themes just in the last 20 minutes. Suzanne, the question that you raised about, to Rich about, I'm a believer in the religion of RL, but how on earth do you create these reward signals and value functions? And Sendhil, your point earlier about understanding that, if the RL process creates this incredibly, high dimensional representation of the world, but we can't understand it. How should we think about that? Niamh, thank you very much for giving that, like the quick, 3-minute overview of how we got here. So we will try and pull on all these threads, because I think, Rich, this clash of views is this is what I would view right now as a $1 trillion clash of views. It's not trivial. And it is, in economics, we have this text from the 1950s called The Rate and Direction of Innovation. And when you describe this clash, it's the money pouring in that is shifting the direction of science. And so I think you've just hit a really hot button for us, and so we'll return to this in a following session. So thank you all very much. I've loved this today. Hopefully everyone else has enjoyed it, and we will see you next month.
Thanks, Ajay.
Bye, guys. Super fun.
Thanks. So look forward to unpacking that.
And that's our show for today. Thanks to Rich, Sendhil, Niamh, and Suzanne. We posted links to our hosts' social media feeds and web pages in the show notes, as well as our podcast webpage located online at insights.intrepidgp.com/podcast. Thanks everyone for listening.
The views, opinions, and information expressed in this podcast are those of the hosts and guests and do not necessarily reflect the official policy or position of Intrepid Growth Partners. This content is for informational purposes only and should not be considered as financial, investment, or legal advice.